Hello, welcome back to LeetCode Daily Life. Today we're going to do longest straightly increasing or straightly decreasing subarray. So let's look at the question. It's an easy, so shouldn't be too bad. You're given an array of integers nums. Okay. Return the length of the longest subarray of nums, which is either straightly increasing or straightly decreasing. Right. So let's look at some of the examples. So for 14332, the straightly increasing subarrays of nums are these. Straightly decreasing are these. Right. Actually, subarray has to be contiguous. Yeah. So like, it has to be like connected. We can't just pick like the first, third, and fifth element. Right. Yeah. So, my first thought for this is that it makes sense to brute force it because we are not dealing with because all the arrays, like all these subarrays, have to be contiguous. So like, let's say when I check one, I check like for the next one, how far I can go, and so like it can go, until at some point it stops. Then you can get the length like of that. So, like let's say for 1 and 4, so this is increasing, right? Well, we can just but then when we look at 3, we know that it is not strictly increasing anymore. It is decreasing. So we can like check from 4 to 3, and then like we can, yeah. So I think a brute force approach would work, but we still have to check whether it is correct. Well, also the length is very small, so it is also possible to just check every single subarray. So we will have n squared amount of subarray. So O n squared. Yeah. Well, yeah. Honestly, I think sometimes like when you look at the size, yes, you can think of an ON solution, but then, well, there is not really a point to do that, I guess. Like when the length is so tiny. So I'm just going to do the most brute force way and just get all of the subarrays, and I'll check all of them. Right. So we want to get the length. So equals the length of nums. Now for I in range n, for j in range, well, to get all the subarray, we have to check every pair of numbers, and including like the overlapped kind of pair. Yeah, so yeah, but we don't want to look backwards. Well, actually, if we look backwards and we check increasing, like strictly increasing, it will be the same as strictly decreasing. So yeah, honestly, we can just do that as well. I mean, it's not clean, but it works. So yeah. Let's just do this. It's probably cleaner. Right. So we're going to check array valid ij. So if it is valid, we can just get the length. Oh, actually, I made a mistake. I said that it will be n squared, but it will actually be n cubed because we have n square pairs. But each check will take on time. Yeah, so it will be n cubed, but n cubed is still fine for such a small bound. So yeah. So if we check that, then if it is fine, so longest sub r, well, I should set it as 0. Well, we guarantee that when we look at one element, it would be a strictly increasing subarray. So setting it as 0 would be a safe number. So if this is true, we want to update our longest subarray to either itself or the length of the subarray. But like for example, if I is equal to j, so if we are looking at one element, well, this is why like the +1 is here. Here, and then we can just return longest subarray here. We want to define check subarray valid. So we want to check two things. We want to check increasing, and then we want to check decreasing. So for index in range I to j plus 1. Actually, we can just check. Oh yeah, we can just check I to j, but we check every adjacent pair. So we check them as pairs instead of like each number at a time. So if nums I is bigger or equal to nums j, well then to nums I plus 1, well then obviously it is not going to be it is not going to be increasing. So we'll just break out of here. Probably want a is increasing thing here. Is increasing will be false, and then we break. So if is increasing, we just want to return true here. Otherwise, we will check is decreasing. We can use the same. We can use the same technique. So this wouldn't go out of bounds because the biggest j, like the biggest value for j is n minus 1, and because we are using n minus 1 as the exclusive bound, the highest it can go for I is going to be n minus 2. So so this thing will only be n minus 1, and that will be in bounds. Yeah. So after we get here, if it is not strictly decreasing, we know that it is going to be false. But actually, let's just reuse the code. We can do this. So if it is not strictly greater, so if it is equal or smaller, well, it's decreasing. It's going to be false, and then we can just break. So we can just return it's decreasing here. Seems like it works. Yeah, it's a bit slow. I'm sure there's an ON way of doing it, but this works. Actually, since we solved this in like 10 minutes ish, we can try to figure out the ON solution. So let's say we have an array like this. So what we can do is like for this, we have two potential, right? Like either actually we have three options. So either the next number is increasing, the next number is equal, or the next number is decreasing. So you need some kind of flag. So in this case, like for 4, this is increasing, right? So we also like need a counter or something. So when we look at like 1 and 4, we can look at this pair. Yeah, so this actually gets me thinking that we can form another array that checks for every adjacent pair. So for this array, what do we call it? Let's call it the adjacent pair array. Well, what would this be? So for 1 and 4, this is increasing, right? So let's set increasing to 1, decreasing to -1, equal. Let's set it to 0. Oh. Yeah. And then, well, so what would this array be? It will be 1, -1, 0, -1. Like, based on the pair, whether it is increasing, decreasing, or equal. So whenever we see something equal, we know that we cannot have any subarray that has both of the numbers, right? So like it is impossible for us to have any array, like any subarray, straightly increasing or decreasing subarray that contains both elements, because this is neither straightly increasing or decreasing. It is equal. So yeah, so actually one way to do it, I think, is to just form this array, and then we can just check like the longest, like 1 or -1 sequences. Yeah, actually, let's look at the example. I think, yeah, I have some time, so yeah, honestly, let's just solve it here as well. Yeah, let's just mute that. Let's call this the solution. We want the ON solution here. So adjacent pair array. Well, it's also a good thing to define the constants. So this would be an array like this, and then now for I in range n-1, well, we want to check each pair. So again, we have nums I and nums I plus 1. That would be every adjacent pair. Well, we just want to check for the 3 conditions. So if it is smaller, if it is like, if the previous number is strictly smaller, then that means it will be increasing, right? So adjacent pair array append, we append and increasing, elif. Well, if it is strictly larger, then it will be decreasing. Lastly, it will be equal. Right. So after we got this, we just want to check for the longest, like the longest equal sequence in adjacent pair array. But we don't want to check for zeros. So, longest sequence. Well, we can. It's always safe to set it as 0. So for for let's just call it for pair for x in adjacent pair array. Let's get some space down there as well. Well, we probably want a current to just check whether, like, to check what is our current sequence that we are looking at. And then we want cur length set as 0. Yeah, actually it would be better if we call it element. So if the current element is equal, well, if the element is equal to the current element, then what does that mean? It means that we can extend our length, right? So 1 plus equals, so we want to increment that. Yeah, actually before that, we should just check if the element is 0, it just basically cuts everything off. So we can just do current element be equal to 0. Yeah, we can set this as 0 actually. We should really use the constants, honestly. Current length, we'll go back to 0, then we continue. And otherwise, we have two possibilities. So either the element is equal, so we'll increment the current length, or the element we are looking at is not equal, right? So let's say like the sequence we are currently looking at is like a sequence of ones, but then we see a -1, so we need to reset the current length and the current element. So current element will be the opposite of what we have right now, and well, because we are doing 1 and -1, we can just do we can just do this to flip the sign around. This is probably not that clean, but I'll just write that for now. We also want to set the current length to be 1. Yeah, and like since we have the edge case with all threes, so like the whole adjacent pair array will be 0. It is possible that we never reach a current length of 1. So that means this could be bigger than the than the longest equal subsequence. So when we are doing the updating, we should update for both of them. Well, that means we can update it outside. So longest sequence be equal to the max of longest sequence and the current length. So if the current length is longer than all of the previous lengths, then we want that. And then at the end, we can just return longest sequence +1. So why the +1? Well, if we have 2 ones, that means we have two continuous adjacent pairs that have 1, right? So let me give you an example. So let's say we have 1, 2, 3. Well, for the adjacent pair array, what will this be? It will be 1 and 1, and that means we'll have a length 2 longest sequence, and basically that means what this means, it means that like the two elements are strictly increasing, right? And this means it is straightly increasing like this. So actually we have one more element than the length of like however long the longest subsequence is here. So yeah, so that's why we have the +1 there. If I didn't miss anything, I did miss something apparently. Did I forget to update or something? Right, so for here it is returning, so that means longest subsequence we got is 1. So if element is well, the simplest way is to just print it out and see what we're doing wrong. So we do have 2 minus 1. So what happens here? Well, if the element is equal to, well, so for the first one, because this is set as 0, it is not going to be the same. So it is going to, I see. We really should set this. Yeah, I'm being a dum-dum. Could have just done that. Yeah. I didn't print anything. That should work. Yeah, nice. And this is the ON solution, which is way better than the brute force one. Well, I'll see you tomorrow. Bye.